Okay, next we will calculate the work done for different systems. Okay, first I will calculate my work done in an isochoric process. In an isochoric process. What is an isochoric process? First we will define an isochoric process. It is a process, okay, in which volume of the system does not change. If the volume of the system does not change in a process, then that process is called isochoric process. So volume does not change, what it means? It means that initial volume will be equal to final volume. And we know that the change in volume is basically the final volume minus initial volume. So if both them are equal, then the change in volume will be 0. Now the work done is given by minus integral of P into dV. If this is 0, then the work done will be. So the work done in an isochoric process is always 0. Now next we have work done in an isobaric process. Work done in an isobaric process. First I will define isobaric process. What is an isobaric process? It is a process in which pressure of the system does not change. Now if pressure does not change, which means that pressure remains fixed. Now the work done in such a process will be equal to minus integral of P into dV. Now here the pressure does not change, while volume will changes from initial volume to final volume. I can write two systems or the same systems with two different conditions. Here the initial volume was this one, the pressure was Pi here. The initial volume was Vi. Now the volume is changes from Vi to Vf. Okay, here the volume is now Vf, and the pressure, which is here the final pressure, is equal to initial pressure. Pressure does not change because the initial pressure and final pressure, they are the same, but only the volume changes here. So it means that the work done will be equal to, pressure is constant, so I will keep it outside of the integral, and we have volume changes from initial volume to volume, final volume into dV. So the work done will be minus P into Vi to Vf. So this will be equal to minus P into Vf minus Vi. I can write it as P into Vi minus Vf. I can write it as PVi minus PVf. This is the work done in an isobaric process. So next we have another process which is called isothermal process, like the work done in an isothermal process. Work done in an isothermal process. So what is an isothermal process? Like a process in which it is a process in which temperature or in other word we can say that the internal energy temperature basically means internal energy of the system does not changes then it is called, then the process is called isothermal process. Now the temperature is constant, and we know that at constant temperature we have a relation PV is equal to constant for keeping temperature is equal to constant. So the relation between P and V at constant temperature is given by this, and if I plot it, okay, let's suppose this is the volume and this is the pressure. If I plot it, the plot will be like this. So here we have this initial pressure and final pressure. Here we have the initial volume, this is the final volume. Here this is the initial pressure and this is the final pressure. Now this is the PV diagram for this isothermal process. This is PV diagram at constant temperature, and this PV diagram is called isotherm. This PV diagram is also called isotherm. Now the work done in this isothermal process is given by, the work done is given by minus P into dV. Now temperature is constant while volume and pressure, they are both changing. So it means that we have to replace this one quantity P with some other quantity which will remain fixed. I can say that we need to remove P from the integration. So we will remove P from above integral. So for that I will use this relation PV is equal to N or T. So P will be equal to nRT over V. So if I put it in above equation, then the work done will be equal to, now the volume is pressure is replaced by this nRT over V into dV. So the volume is changing from initial volume to final volume. So we have this nRT, they are all constant, so I will bring it outside of the integral. So we have minus nRT, and here we have dV over V, and the volume is from initial volume to final volume. Now next I have to solve this integral. So the work done will be at constant temperature will be equal to minus nRT, because temperature is constant. N is constant, R is constant, so that's why I'll keep it outside of the integral. And here we have integral of dV over V is basically natural log of that quantity, and we have this Vi to Vf. I can write it like this, minus nRT, okay, and we have upper limit ln Vf minus lower limit ln Vi. I can write it as like this, minus nRT. Now natural log of A minus natural log of B is basically equal to natural log of A over B. So we can write it like this, ln Vf over Vi. So this is the work done at constant temperature. So the work done is, the final expression is minus n RT, and we have this natural log of Vf over Vi. This is the work done at constant temperature, or we can say that at isothermal process. So I will stop my video here, and the next video I will proceed further. Thank you.